Hello guys, my name is Gürkan Çelik. I am new research assistant of the department, and in this semester we will be giving you the Digital Logic Systems Laboratory with Özge Hoca, Dr. Karadağ, and we plan that there will be 4 experiments, and with these experiments you will be given your grades. And let me start to the explanation. You can contact me by email, whether it's related to the lab or not. I can definitely help you. In this lab we plan to use Logisim, Logic Simulator application. When you type the Logisim in the Google, click the third button, and then from download button you can download, and it will be downloaded executable file, so no need to set up anything. So when you open the application, you will see this panel. These tabs almost similar with any other application. File, edit. There will be different project and simulation. I will explain these tabs in the ongoing weeks. There will be 2 main buttons. With this button you can change the value of the values within the circuit. With this cursor you can edit and select and move the components of the circuit. You can label it with this button. This side is also like shortcut of the application, because whatever you can see here, it's the same as from here, so shortcut. This means input, this means output, this is NOT gate, this is AND gate, this is OR gate. So I will explain these bars also later. So let me begin with a simple example. This is basic Xor Gate. Okay. In order to obtain Xor output with 2 input, you have to add 2 NOT gates. After that, 2 ANDs. Output of 2 ANDs will be input of 1 OR gate. So let me start. You can click here with NOT button. Also, as I told you, same as here. It's same. So we need two AND gates. When you click this AND gate, you will see like 5 inputs, 1 output. But in this circuit we have 2 input, 1 output. So you click here and you will see the properties of this gate. You can change with this panel, you can change its facing from south, north, whatever it is. You can change the data of bits. So in this example we will use 1 bit. It's okay, but for further examples you may need multiple bits as well. So for now it's okay. You can change its size, you can change number of inputs and so on. So make it 2 bits, 2 inputs, sorry, then it's okay. So you can line it, you can create line with this, like this. Okay, let me change the locations of the gates. Also we need to change this AND gates inputs and connect these two wires, and this will be our inputs. And as you can see, the before NOT gates wire, you have to get to another AND gates input, so from here to here as well. So that part is already done. So we have to add one OR gate. Also it will be two inputs, one output. So with this it's okay. Now just the inputs and outputs missing. Just just be noticed there will be colors changing in the wires when I add this input. As you may see, the 0 means dark green, and the 1 means light green, and from blue to red it will be changed shades of greens. So I add the second one as well, and also I will add the output. So I think we're done here. So in order to test it, you have to click this button. So you can change the value of this input. When you change it, please be aware of the changes of color change of the wires. When I set it to 1, then the output will be 1. As you may see, it's okay. When I change it to 1 1, and then the output is 0. So in order to analyze the circuit, we have to click the project tab, and then there is analyze circuit. There will be two inputs, A and B, one output, X, table as same as at the picture. The truth table is the showing easiest way of the circuit, so it's quite important for this lab. The expression is also how you can obtain the output value with input values. So it's like inverse A times B plus A times inverse B equals to output X. So minimize version is you can express this equation with sum of products. Please be aware of chains over here, or products of sum. We will explain these differences at the following weeks. So, and also let me show some other things here. There are some wiring components, gates. We already have Xor gates over here, but just wanted to make you understand one of the easiest circuits. The memories, flip-flops. We have input outputs. We have base. So for output we can use LED as well, same as the output value of this output of this. So what is the difference between these two? Just be sure what chains over here. As you can see, both are indicating the same, and also really similar. The difference between these two is you can change the output and buttons bit. So if you have larger bits, number of bits, you can change the output of as that number of output bits. But with LED, you cannot change the number of bits. For example, if these two components have 2 bits, make sure just be aware of the change the color of the wiring. Okay, 2. So as you may see, there is 2 over here, 1 over here, which means that this part of wire indicates 2 bits. This part indicates 1 bit. So if you change this part with 2 bits, then it's also okay. You have to change that one, and after that one, after that one, then it will work. But I'm now taking it back. So you can change this also 2 bits, but there will be some error, but just wanted to make you understand. But with LED, you cannot change the number of bits. So when I put this also 1, then it's okay. And also we have splitter, for example. Splitter means you have one input or one output, multiple input, or multiple input, one output. So in that case, you have 2-bit input. Let's make it 4-bit and 4-bit input. Okay. So this means you have 4-bit input. There will be some error because this indicates 1 bit. This requires 4-bit input. So in order to fix this, you have to change the input of output of this input will be 4. Then the color is gone. The error is gone. Okay. So if you wanted to check this, or this, you can connect like this, so you can see the difference when you click the lowest priority bit into the 1, then you will see 0th bit will be 1 and the LED will turn on, and the others also. As you can see, splitter works like that. So okay, one more example also I need to show you. If you are building the more complicated circuits, you may want to make it simplified version. So when you select them all, whichever you want to simplify, you can just realize that there will be 2 inputs, 1 output, right? So if you click this, you create sub-circuit like this: 2 input, 1 output. So if you save as like Xor Gate, there will be appeared Xor Gate button. So if you just add this, also you can copy as much as you want. So you will have 3 Xor gates with really simplified version. So you can behave that circuits behave as like sub-circuit of the previous one. Okay. So how you will see the inside of these circuits? You have to click this, yes, and then click this. You will see the search button thing, and then you will double click and you'll see there is the 2 input 1 output, and the real version of the circuits. Okay, and let's create a 3-bit synchronous counter, and I already took the equations from anywhere else. If you don't understand this, I will record another video. It's okay, but for now, just wanted to show how you can build such equations circuit. There will be 3 JK flip-flop, as I told, and the first one has one, like J input and K input equals to 1, same. First, for the second bit JK flip-flop, this input's also same. For J1 and K1 inputs is output of the JK flip-flops output. Okay, and the third JK flip-flop input is outputs with the multiplied between second JK flip-flops output and the first JK flip-flops output. Let's create it. You have to click JK flip-flop, add here. In JK flip-flop, there is 3 inputs over here. With 1, which makes output 1, sets the flip-flop output. Enable makes the enable or disable the flip-flop, and this resets the output. Okay, you have to add three inputs over here. Okay, and also you need clock signal, which helps to work synchronously the flip-flops, 3 different flip-flops. So in order to make the first inputs equals to 1, you have to get power and enters both of the inputs. So to show the output, you have to connect this. So you have to enable this enable input, otherwise the flip-flop will not work. I want to show you how. As you can see, there is no changed output. Okay, but if you change the input of enable wire into the 1, then the output will change. Okay, and like in first click it changed to 0 to 1, and then second click it changed 1 to 0, same as toggle, right? So what is the difference between this JK flip-flop with toggle flip-flop, T flip-flop? Actually, for now it's same, total same, because if you may see over here, at least value of the counter 0 to 1, 1 to 0, 0 to 1, 1 to 0, so toggles directly. But for higher bits it's not like this, so it's not changed directly. It needs some signal from the lower level flip-flops output. Okay, for now, for this also it's not directly toggles, it waits some signal. Okay, so for second JK flip-flop we need input as the output of the first flip-flop. Okay, so we add this JK flip-flop as well. We connect this, we enable this, and we reset values into the 0. Okay, and output of this, the least important bits output, directly enters to the JK flip-flop. Okay, and the clocks will enter and gets the signal from here. So output of the second bit is shown here. So let me see. Okay, let's make 0 all the bits. Okay, then want to count from beginning. Okay, this is 0 0 output now. If I click this, 0 1, and then more 1 0, and then more 1 1, and then this will be 0 0 again. Okay, which as expected. Okay, so the most significant bit input needs to require like Q1 and Q2. Okay, multiplied by Q0. Okay, we need another flip-flop over here, so we need AND gate over here, so we need to change these to west and 2 inputs. Okay, one is here, one is here, and then output of this will enter to the JK flip-flops. Okay, so clock signal gets from clock as well, same. So 1, enable 0. Okay, and also Q. So it's 0 0 0 now. Let me see, is there any, does it work properly? 0 0 1 now, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1, and 0 0 0. So it works quite fine. And for now I think it's okay for this week. Just we want you to check this program and create another examples of the circuits. And if you have question, as I told you before, you can send email to me and I will reply it, and we will create a YouTube channel for this. From that YouTube channel you can watch whenever you want and how much you want, as much as you want as well. That's it for now. Take care, stay safe. Bye.